So we are going to try to do some more parent function graph and then some extra graphs with the transformations, okay? This one says, example 3, graph the parent function y equals 4 to the x. Remember, these functions are called exponential functions. And our parent function, it's always y equals the base. Your b is your base, okay? Your base. Now, if your base is bigger than 1, in this case, this one is, that will be your exponential growth. So we don't need to graph it out to already be able to answer some of these. So when b is bigger than 1, and remember your exponent x has to be positive, then we know it's going to be a growth graph. Just like any other transformation, your a is always going to be the coefficient in front being multiplied to your base. Your h is always going to be adding or subtracting to x, and your k is always going to help us shift up or down. And write this in this little oval here. You will have different bases, okay? So different parents. So different base will result in different parent equation. So you cannot just use the same outputs every time. You have to look at the original and see what parent function we need to use. In our case, we have 4 is your base, so that allows us to use 4 and then raise it to whatever x input that we have chosen. We will go with negative, let's do -5, -1, 0, 1, and 5. Those are the x's we pick. Now, yes, you can pick -2. Yes, you can pick -4. You can pick -3. It's really up to all of us, okay? So first, we are going to go 4 to the -5, which is going to be 1 over 4 to the +5. Now, 4 to the 5th, guys, is 1024. Now, it's okay. I'm going to go up here. It's okay to write this down, but clearly we don't have 1224 grids when we do this positive one down here. But it tells us that it's getting really, really close to 0. That's all that's going to tell us, okay? Then we are going to do 4 to the -1, which is going to be 1 over 4. 4 to the 0 is going to be 1. 4 to the 1 is going to be 4. And then 4 to the 5th. Okay, we just did that. And again, we don't have 1024 grids. But this one right here tells us it's growing so fast, exponentially fast, okay? So when it's -5, all I would like for you to do is 1, 2, 4, 5. It get close to 0, but don't really quite hit the x-axis, since we would never get a y value at 0. And draw in the asymptote right away as well, so you know that you can't really hit the x-axis, okay? When x is -1, we know it's a quarter. When x is 0, we will go up at 1. When x is 1, we are going to be at 4. When x is 5, it's 1024 up. But we don't have that many boxes, so we will just graph these 4 right there. Okay, just like that. All right, let's answer some questions here. Since it is the parent function, we don't have h and we don't have k. We don't have any x-intercept for the parent. Your domain for all exponential function students is always going to be all real numbers. You do always have the same y-intercept for the parent. Doesn't matter the base. Isn't that magical? Your range is going to be from 0 to infinity, or you can write y is bigger than 0. Since 4, which is your base, is bigger than 1, it's definitely increasing interval, and it's increasing from -infinity to infinity, the entire domain. That leaves us decreasing being NA. Your rate of change will vary since it is non-linear, and it's 1 to 1. We do have a horizontal asymptote at y equals to 0 and no vertical asymptote. All of these information are true for all and any parent function. Let's go try this refresher down here, and then we're going to work out one more parent before we move on, okay? Now, if your A is negative, if you guys remember the refresher, it's going to be a reflection over the x-axis, reflection over x-axis, or we can also call it a vertical reflection. Whichever one you want, just pick one, okay? Now, if the absolute value of A is less than 1, guys, this is going to be a vertical compression factor, okay, of whatever that is. So, i.e., if your absolute value of A is like 1/2, then we're going to say vertical compression factor of whatever, 1 over A, okay? Whatever A is, not 1 over A, absolute value of A, okay, of A. If the absolute value of A is bigger than 1, guys, then it's a vertical stretch, okay, factor of A. So let's say A equals 3, then it's going to be a vertical stretch factor of 3. H, if it's positive H, we go right, okay, H units. If it's a negative H, we go left, H units. These are all exactly the same. If it's positive K, we go up K units. If we have a negative K value, we go down K units. Okay. Now, steps to graph any function. And you've seen these 6 steps already in prior graphs. Number 1, figure out what our parent's going to be. Okay. Again, it's going to be different every time based on the original function and the b value. Make a table of value for your parents. Find out what AH and K are. That will help us do the transformation. List out your transformations. Make a new table of value using your transformation. If we have an x plus h here, because h is going to tell us go left or right, and the a value will need to be multiplied by the a will be multiplied with the y and then plus k, okay? And then you're going to graph your new points. Now we are going to do one more parent function just to show you how many we have. Parent function. This one says y equals 1/3 raised to the x. Guys, so far we have done 3 parent functions, and each one has a different base value. So this first one, we have a base value of 2. That's a parent function. This one is 1/2. That's a parent function. That's decay. This one's going to be about a base of 4. That's growth, since 4 is bigger than 1. Now we are about to do another parent function, 1/3. Guys, we're not going to do all the parents, but you should be able to have the skills to do each and every parent table, okay? So for this one, we will pick, remember, you can pick whatever value you want for your input as long as you need to pick 5. So for this one, we can do -2, -1, 0, 1, and 2. Earlier, we picked -5, -1, 0, 1, and 5, and that was really giving us some really big values. So we are going to do 1/3 raised to -2, which is the same thing, guys, as 3 over 1 to the +2. Whoops, that's not coming out. Let me pinch in. So that's going to be 9. Okay, 1/3 to the -1, which is the same thing as 3 to the 1, which is 3. Any number to the 0 student is going to be 1. 1/3 to the 1 is 1/3. 1/3 to the second power, guys, is going to be 1/9. Okay, we can plot these. So let's go and do -2 up 9, which is this right here. -1 up 3. 0, 1. Look at that y-intercept. Same y-intercept. Doesn't matter what parent function. 1 and 1/3. And 2 and 1/9. As you can see, guys, it's getting closer and closer to your x-axis, which is your horizontal asymptote. If you have a pencil, just go slightly. Can you guys see that go a little bit beyond here? So I can see that you have your asymptote graphed in. So now connect all your dots. Make sure you have 5 on your table. And if it's slightly off the grid, then feel free to, go off the grid. But when you have like 1024, clearly that's not going to be possible. So your h and k will be 0, 0. Your x-intercept, you're not going to have any. Now, even before we graph, we knew it was going to be a decreasing interval since your base is going to be 1/3. So that's going to be a decay graph, which is decreasing over the entire domain, okay, from negative infinity to infinity. That tells us, here's our domain. Increasing is going to be none. Rate of change, it is not a line, so we will write varies. You do have the horizontal asymptote, y equals to 0. We don't have any vertical asymptote. Yes, this is definitely 1 to 1. Your range is going to be y is bigger than 0, or you can write interval notation, 0, infinity. We do have y-intercept at 0, 1. Students, this chart is the same for every single parent function, okay? Now, give me a sentence or two to compare your example 4 when your base is 1/3 and example 3 when your base was 4, okay? What's the difference between the two? If you pinch in, what's the difference between the two? What do they have in common? Give me a sentence or two. Okay, so I will wait to read those when I collect your papers. So the remaining question says, graph each function, then find all defining characteristics. So we have 5, 6, 7. We'll do these together. And then 8 is the one that you're going to do it on your own, okay? Okay, let's go do 5. 5 said f of x equals 3 to the power of x minus 4 minus 1. And first, your base is 3. So that allows us to go and write your parent function. Y equals 3 to the x. Yes, write it right away. Then we are going to say, okay, your b value is 3. So that's why it's y equals 3 to the power of x. Your a value, remember, a is always going to be 1 times your base, since you don't see any number in front of that base 3. So that's why it's 1 time. So a is 1. Your h is always going to be with the x. So that's going to be a positive 4. Your k is going to be the one that's moving things up or down. In this case, it's minus 1. So we can fill out 4, negative 1 right away. Let's go and plug in some values. We can pick any 5x that you want in the parent. So negative 2, negative 1, 0, 1, and 2. So 3 to the negative 2 power, students, is now 1/9. 3 to the negative 1 equals 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Then that's going to allow us to transform. Remember, h is going to be added with the x, and your k is going to get minus with the y. We have a value of 1, so we don't need to multiply that, okay? Okay, let's take all of your x's here and plus 4. I wrote plus h, but we want plus 4. And then change that here. Then take all of your y's from the parent and then minus 1. So let's rock and roll. Negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. Then we get 5. Then we get 6. 1/9 minus 1 is negative 2. Negative 8/9, my bad. Negative 8/9. 1/3 minus 1 is going to be negative 2/3. 1 minus 1 is 0. 3 minus 1 is going to be 2. 9 minus 1 is 8. So we are going to plot those.